In question 11, we're given a price demand function of 25,000 over x, and I say it's a price demand function, meaning that d of x actually gives us a price. So even though it's a function of x, the output is a price. Well, we're asked to find the average price over the demand interval 300 to 550. Well, to find the average value over an interval, we recently learned that we multiply the front of a definite integral by 1 divided by the right endpoint of the interval, which is 550, minus the left endpoint of the interval, which is 300, and that fraction is multiplied by the definite integral of the function evaluated from 300 to 550. This is, although the material is new and the less familiar than most other material on the test, this is probably one of the easiest questions on the test. Everybody should get this right. And so that's the way I've set the calculation up. 550 minus 300 is 250, and then I have factored this 25,000 out, which is one of the properties of integration. We're allowed to do that. If there's a numerical factor that's common to all terms, we can factor it outside the integral. And so that leaves us with 25,000 over 250 times the definite integral of 1 over x from 300 to 550. 25,000 over 250 reduces to 100, and the antiderivative for 1 over x is the natural log of x, or more properly, the natural log of the absolute value of x, but everything here is positive, so we don't have to worry about the fact that it's absolute value. And so we will evaluate that antiderivative at 550 and subtract that antiderivative evaluated at 300. And so that's the natural log of 550 minus the natural log of 300. And referring to or recalling our quotient property of integrals, this can be simplified by taking the natural log of the first value, 550, and dividing it by the second value, 300. So this is just a number. We can enter this calculation into our calculators and get the result $60.61. And that's all there is to that question. Now in number 12, we're again going to use we're going to calculate a definite integral for a more abstract reason. We're just asked to find the area bounded by the graphs of the functions f of x equals x and g of x equals x squared, and the interval is in this case 0 to 1. Now I believe on the practice that I passed out it says 0 to 2, but and you could certainly do that, but you would get a negative answer, and that won't be the case on the test. One thing we will have on the test excuse me, is a graph that will show this function f of x and this function g of x, just in case there's any doubt as to which function lies above the other. There will be a graph where you can see, and in this case f of x equals x is a diagonal that is above the parabola x squared on that interval. So the area between the graph of two functions is a definite integral, on an interval, is the definite integral of the first function, the upper function, evaluated on that interval, in this case 0 to 1, minus the other function, the function that is below, evaluated on the same interval 0 to 1. Well, when you have a difference of two integrals, you can bring them together into one, and so this this negative x squared comes inside, and so we're evaluating the definite integral x minus x squared on the interval 0 to 1. Using the power rule, the antiderivative of x is x squared over 2, because the exponent here is 1. 1 plus 1 is 2, and the reciprocal of 2 is 1/2, and so that's 1/2 times x, and the 1 got added to the exponent here, so that's why this is a 2, x squared over 2. And then you do a similar thing to this term. 2 plus 1 is 3, so this exponent is raised to the third power, and the reciprocal of 3 is 1/3. And so when we multiply 1/3 times negative x cubed, we get negative x cubed over 3. And then we evaluate this antiderivative at the top value here, at 1, and we subtract this antiderivative evaluated at 0. Well, this antiderivative evaluated at 0 is just 0, because 0 squared is 0, divided by 2 is 0, 0 cubed is 0, divided by 3 is 0, so this is just 0, and it integrates out. And 1 squared is 1, 1 cubed is 1, and so we have 1/2 minus 1/3. And I haven't shown those steps here, but if you give these a common denominator, you would have 3/6 minus 2/6, and that would leave a value of 1/6. So that's the answer to this question.